Hello, Keith Rucker here at VintageMachinery.org. Guys, today I got a little project, kind of a little bit of a repeat project. I've done some stuff similar to this in the past, but I've had a viewer that brought in a Golden's 3-roller cane mill used for crushing sugar cane to make syrup and sugar from, etc. This was a very common piece of an implement, I guess you could say, that would have been on pretty much any farm down here in the deep south back in the day. And basically farmers would grow their own sugar cane, and then they would process that on the farm. They would run the cane through a cane mill, which would crush that cane, squeeze all the juice out of it. They would take that juice and then boil it down until they got either a syrup, cane syrup, or they could continue boiling it down and actually make sugar from that as well. Very similar process that we use today to make sugar in a sugar refinery, but just more crude and more just agrarian, I guess you could say, in the way it was done back in the day. There are quite a few people in the area down here that have kept that cane grinding tradition alive, and finding these old cane mills and getting them restored and using them is it's a kind of a popular thing amongst certain people in this area. So I've had several requests over the years to work on these cane mills, and I'm probably one of the few people around that actually fool with these things. So I've had some people reach out to me to help them out. This gentleman actually came all the way from Louisiana to bring these parts up here, and I've had them way too long, and I need to get this project finished out. I know he's not going to need this until this fall when cane grinding season is, so I've kind of had it on the back burner, but I need to get it knocked out and off the list, so we're going to get started on that today. Actually, we started on it a while back, and you're going to get to see some of that video here in just a minute. But let me tell you what specifically we were needing. The bearings on this thing were just completely shot, and basically on the tops and bottoms of these rollers, they had Babbitt bearings that would just serve as a bearing surface. And over the years, on all three of these rollers that go in this thing, the bottom bearing, the one these rollers stand up straight, so but all three of those rollers had become, or all three of those bearing surfaces down in the bottom, the shafts, had become tapered from where it had just worn over the years. So what we needed to do was get that welded up. It was too much of a job for spray welding. I actually got a spray welding unit here in the shop. I've never done any videos with it. I'm sure if you watch Adam Booth, you've seen quite a bit of that kind of work being done. But the wear on these were so great, it was really beyond what spray welding could really do. So we actually welded these up. This shaft that goes through these rollers is made out of steel. The roller itself is cast iron. It's a two-piece thing here. They just press this in, shrunk it in place. So we welded these up, and when I say we, I took this down to my buddy Jim Bollinger's shop down in Florida. Jim is a very good welder. I'm an okay welder. Welding is not my forte. I can make a passing weld, but I'm not a great welder, and I really wanted to get his help on this. He agreed. So I was down in Florida on business back in, I think it was in April. And one evening I went by his place, and we spent a couple of hours out there. Actually, we were out there in the shop until rather late that night, but we got the bottoms of these three shafts welded up so that we could then machine them. So what I'm going to do now is we're going to actually cut to some video that I shot down in Florida at Jim's shop and show you this process we did. So you can kind of see the problem we got on these rollers here. Over the years, these of course would have been in Babbitt bearings, and what happened is that the Babbitt wore down to the shell behind it, and they started wearing at a taper. See how both of these are tapered? These should be straight shafts, but they're tapered out. So today, what our goal is we're going to actually weld these up. I mean, you look here, we got a big chunk even missing out of that one right there, but we're going to weld these up, and I will then come back later on the metal lathe, and we'll turn them back down and hopefully end up with some nice journals that we can then pour the Babbitt back to. Basically just building material up on these.
So we're gonna build this up today. Of all the things I do not have a weld positioner. So we just did what I do best, and we just rednecked the hell out of it. And basically these are the tops to a couple of pipe stands, and they're just a couple of rollers. This is cast, right? The roller part's cast.
The roller part is cast, but the shaft that goes through here is steel. So it's pressed in there, and it looks like they may even have some babbitt that they poured in there to kind of hold it all together.
Yeah, and so the way we're going to weld this is Keith is going to be the weld positioner. He's going to rotate it.
Just like that. That's my job.
We're going to do this in short arc, so we get a kind of a high buildup. We're going to run the wire feed speed on the machine pretty high. We're going to use the R70S6. We're not looking for pretty weld here. What we're looking for is overlapping welds that make a nice continuous bead, because he's going to turn this in the lathe. He's going to turn it back. So all we're looking to do is build material and get it built back to where it should be before it ran out of babbitt.
There you go.
Welding gas is 75/25, mainly because that's what I have here in the shop.
It's a good reason.
Grounding, the way we're going to do grounding here is we've got a piece of soft copper braided material wrapped several times around the shaft, clamped to the workbench. The workbench is also grounded, so we have a continuous ground. It's not grounding through the rollers. It has almost like a commutator and brush sort of setup here. And then we're going to get the shaft cleaned up real nice. We're going to throw it in the oven for a little while, get a little preheat in it, and we're going to weld this thing up.
There you go. So we'll be back in just a little bit and show you a little bit of welding.
All right, let's get her done.
Let's do it.
All right, so what we're doing is we're just putting a little preheat in here, just general moving it around. The reason we're doing that is it takes a lot of energy out of when you're welding in short arc to pinch off that piece of wire and cause it to jump across and transfer. And part of that energy that's used up is used in to preheat the base material. So for every, relatively speaking, for every little bit of heat or degree of heat we can add into the base material, we get a little bit better penetration. We're welding in short arc, obviously, today, because that's what we have. That's the gas that I have. And we're not really looking for a deep-rooted penetration. What we're looking to do is just to build this back up. This thing turns at like, what is it, like 3 RPM or something?
Yeah, real slow.
Super slow.
A mule is literally walking around in about a 50-foot circle.
Just powering this through the shaft to keep us turning.
Right.
So we're not looking for, we don't have a lot of pressure here. There's not a lot of distortion. But what we do want is to put a little heat in there, because one thing, we don't know the base metal, right? So we don't know what this base is. And when we have something that's super cold and then we dump a ton of heat into it, we get a differential there. And that differential, that cold, is the heat's going to run to the cold. And when the heat runs to the cold, if it has a lot of carbon in it, we can get brittling because we're essentially quenching to the cold. So this isn't like any crazy scientific thing we're doing. We're really just aiding ourselves in it. Just slowly building up heat in here. This piece is too big to put in my oven behind the shop, which is literally an old oven. And I usually put parts in there and I get them up to a couple hundred degrees, and that satisfies most of what I do here in the shop. So we're getting some
heat.
We're getting some temperature. You know, one of the other issues that we run into is this is a giant heat sink here, so it's gonna pull a tremendous amount of the heat away as we're welding. And so slowly we're adding heat to everything. It's the best I can do to bring the temperature up slower, besides of course having a proper preheat oven. No matter how big of a preheat oven you buy, the next part you try to weld will always be bigger than your preheat oven. So the way this is going to work is, since we don't have a weld positioner, what we're going to do is Keith's going to be my weld positioner. We're just going to do the best we can. Again, it doesn't matter if the width of the weld bead varies, because we're going to machine it all back off. We just want to lay it down consistently, have no gaps in our coverage here. Our brush, if you can see over here, is a piece of copper wire wrapped around the shaft several times, and then it's grounded to the bench, which is also grounded here. As a matter of fact, just for good measure,
there you go.
We'll ground it all together there. And then I'm just going to start on here, and when I say faster, Keith's going to go faster. When I say slower, Keith's going to go slower.
And you're going to start by building up that little hole.
Yep.
Yep.
We got a little divot here where it looks like water sat in here, so I'm just going to do a little circular fill. It's not going to be pretty. We know that. Cover?
Cover.
That's what's happening. We're starting to get really hot. Let's give it just a minute. The whole center of this thing was
Red.
glowing red, but it's laying in there nice. And
Oh, it's beautiful.
you can see where it speeds up and slows down, but I mean
It ain't gonna matter.
yeah, it's not gonna matter when we're done. But that's why the bead gets narrower and wider.
So this type of welding you're doing is making a wider bead. Is that what it's doing?
No, so I'm welding in short arc. So basically, there's 3 modes of MIG. 2 are pretty common. Short arc, where you have a short circuit, it pinches the wire piece of the wire, little bead transfers across. There's globular transfer, where it actually jumps, makes a ball on the end of the wire and a big glob, and that's a very narrow voltage range. And then you have spray transfer, where we're literally spraying like almost a vapor. It runs a much higher voltage. That will give us a wider profile, a deeper root, but it doesn't give us quite as much buildup. It's a really good penetrating weld, but for what we're doing, we don't really need a lot of penetration. The short arc will work fine, because again, we're just putting material back to machine it off.
That's right.
Again.
That's right.
So what was happening here is we're just welding on one spot. If you're looking at it in a cross section for so long, we built up a lot of heat, and all of a sudden you can see the puddle starting to widen out here. Opposed to here, the puddles are smaller. They're widening out because we're putting so much heat in it. It takes so much less heat to melt the base material now, because the temperature is so high. So much energy. It's really energy. The base material already has so much energy in it at a high temperature that it doesn't take that energy that the thing normally uses to make a weld bead that looks right, and we're making this big fat wide weld because there's already so much heat energy in it, because we put all the energy around and around and around in one place.
Yep.
If that makes sense without
Okay.
sounding too nerdy. I speak nerd fluently.
Well, guys, I think we're going to call it quits here on this one. It's built up. To me, it looks like it's built up higher than the root all the way out. Yeah, we got some unevenness in there, but I think we've got plenty of metal to take off. I think it's going to clean up just fine. And I like the way it looks. I mean, I think, yeah, it's probably not the most beautiful weld, but for someone hand spinning it and going around and inconsistent speeds, I'm happy with it. I'm very happy with it, and that should clean up just fine. So, this thing is as hot as a firecracker, but we're gonna go get the smaller rollers now and try to do the same thing to those.
Yeah, I got well-positioner Keith here.
There you go. So it's actually been about 4 months since we did the welding on this, and what ended up happening is it was so late when we got through this, and I had another good hour I had to drive to get to my hotel that night, that I left the rollers at Jim's shop so they could cool down properly and nice and slow. And they were just too hot to handle, so I just left them there and was going to pick them up on another trip, and it just took a while for me to get back down there to get them. Actually, as it turned out, I had someone that had picked some stuff up from Jim and was coming through the area, and he brought them by and dropped them off to me, but I do have them back in the shop now. Here's the finished weld up job on them. I think we got plenty of material there to take off. Hopefully we're not going to have any voids or pockets or anything down in there, but even if we do, on a Babbitt bearing, these things turn really, really slow. If there's anything like that, it basically turns into an oil pocket. It's not anything to be overly concerned about, but hopefully they're going to clean up nice and clean. So let's get on with this project. What we need to do now is actually turn these down and get some good journals. Before I do that, each of these shafts has a center hole in it. The center hole is filled up with crud and stuff. I'm just going to take a hand drill and a center drill bit, and we're going to try to clean those up so that we can put a center in these to get some nice support over on the lathe and start trying to turn those down. So center drill and a hand drill. This is full of dirt and crud and whatever, rust. I'm just going to kind of clean it out. Actually, I need to go up a size. Let me get a bigger one. I think this one will work a little bit better. All I want to do is just kind of clean that up, have a good center that we can use. All right, I think we got all three of those on this side cleaned up. There are center holes on the other side. I'm gonna flip them around, and at least on two of these there are. And we'll clean those up as well. All right, that'll help me out over on the lathe. All right, we are over on the lathe now. I've got it just chucked up in the 3-jaw chuck on this back side, and I'm mostly concerned with the journals on this side. These were really worn. These have got some wear. I'm going to clean these up at the end, just basically get them trued up. It looks like someone hit these with a grinder, and we're just going to basically get it down to a nice size. Now, the nice thing about this is these are all going to have Babbitt poured on them, and while ideally all these shafts will be the exact same size, we will pour the Babbitt to match the shaft. So really the diameter of this is not anything critical at all, because the bearing will be poured against the surface here for each one of them, so it'll be a perfect match for that particular one. Again, ideally we'll make them all the same size. On the tops up here, I may just have to clean them up and go with whatever it turns out to be, because I don't want to take any more material out here than I have to. We could have welded these up as well, but I just didn't see the need to do it. These were severely worn. So yeah, let's get in here. We've got it set up, you know, again in the chuck here. We got the center supporting it on this end. It appears to be running remarkably true to be as old as it is and everything else. So let's get in here and let's see what kind of, yeah, we'll come in here. That seems to be about my highest point right there. I'm just going to kind of come out here. We're just going to take a rough and pass down through there. It's probably not going to hit everywhere, but I'm going to just let it go all the way across. Tell you what, we'll cheat here. It's going to cut there. We'll let it cut through that one. Got a little bit of hitting right there. There we go. Let it cut across there. And that's cutting real nice. All right. We'll take another 100th thou here, 2, 4, 6, 8, 10. And just let it cut across. We want to take a couple of measurements here. First thing I want to do is just kind of get an idea of what this shaft was originally, and it looks like it's just under 2 inches. This may have been turned down before because it's about 60 thousandths under 2 inches. Let's see. Yeah, it's close to measuring 15/16. So I may just shoot for that, which is our 1 inch 15/16, 1.975 or 9375, excuse me. And let's see where we're at up here. We're just a little over 2 inches. So I'm gonna do a 50 thousandths pass on this. Actually, I'm gonna do 60 thousandths. See where we're at now. It's cleaned up pretty good so far. Got a couple little pockets in there. We may take this down a little bit undersized. Again, it's really not critical what it is, so I'm going to take another 50 thousandths. That'll put me at 1 inch 900, 240, 50 right there. Should be cutting into that material above it. We're just going to go ahead and let it clean on up all the way up as far as I can go, which is right there. And I think that is going to be good. We've got a nice finish on there. Couple little inclusions in there, but nothing that I'm concerned about. All right, I'm going to kind of chamfer that bottom edge down there. Steeper angle on it there. I'm gonna just take some emery cloth and polish this up a little bit. That was medium grit on the first round. This one's just fine grit. Blend all that in. And we're going to call that journal done. Again, there are a couple of little small inclusions in here, but on that Babbitt bearing, everything's below the surface. So that'll just be a place that the oil can ride around. No big deal at all. I'm happy with that. All right, we're going to flip this part around and get the other side cleaned up. All right, the part is turned around. And just take a pass through there and try to clean that up. On this one, I'm really not worried about what size it ends up as. Again, the Babbitt will conform to whatever the diameter is. I just want to get it cleaned up. And you can see some of it's ground right in that area down below the surface. So we're going to have to cut a little bit out to get that to clean up. I just dialed in 60 thousandths on this pass. And I don't think it's going to quite clean up. It might. Look at there. I think that's about perfect. I might need to just fuzz a little bit more off, but I think we're going to be in good shape. All right. Let's look and see what we got here. Yeah, we just got just a couple of little marks down there. I'm going to maybe take another 10 thou off, and I think it'll clean up just fine. Might be one tiny little inclusion in there, but we're not going to worry about it. All right. I'm also going to just come over here and real lightly just touch on this. Try to get this cleaned up a little bit, where at least right now, if you look on there, it's kind of worn got some places worn in it. I'm just going to take a real light pass and try to clean that up a little bit. There's like individual grooves on there. I just want to try to get that all roughly the same diameter, because I can tell there's an area down here where it's kind of worn down, where that cane has just gone through it so much. So we'll true it up while we're at it. I'm not taking much off here at all. Take a little bit heavier cut as I get down in that bottom, so that's worn down there. All right. That roller is done. I'm gonna pull it out and we'll do the next one. All right, we got our big roller on here now, and on this one, we're only going to turn this side. This side up here has got a contraption that's not original to it. It's got actual roller bearing on it, and I'm not going to try to mess with any of that. It's not the way the thing was original, but it's actually not a bad design, I don't think, and we're not going to try to modify it. It's working. So we're going to clean up this bottom journal though, and that looks like it's a larger diameter. I'm just going to measure on this end. So yeah, this is about 2 1/8 inches. We're just going to start with a rough pass across here. I'm going to have to, I think I'm going to have to do is actually turn this cutter a little bit so that it can reach up in here. We're just about to hit on this shoulder, but we're not quite up in there. So, easy fix. We'll just loosen up our headstock here. Or not our headstock, but our tool post. And I think that angle there will allow us to get in there. All right, let's take another pass here. All right, guys, I have changed that insert out, and I'm making lighter passes. I've still got a little chatter going on. We're just going to work through it. This long shaft here, and with that pulley on there, it's just got some vibrations in here. Not much I can do about it, the way this setup is, but we'll get through it. It's cleaning up pretty nice though. Still got a couple of voids in there right now. Just taking about a 20 thousandths pass here. It starts out good. I think it's harder right here in this section. We're getting some chatter there, but then it gets better. And I think this has to do with the hardness of the material. Probably just the way it heated up and cooled down. But I think we can get it out with a light pass at the end. All right, we're getting a smoother finish, still a little rough though. I think we got most of our voids out of there. I'm just gonna feed in just a thou or two and fuzz across there and see if we can get that chatter out. So this pass here, I basically just am making another pass across there, and I'm gonna do it probably again up to blank pass without feeding in at all. We're just trying to get that chatter out. And it's still cutting ever so slightly right now in some places there. So hopefully we're going to get that chatter out by doing these finish passes. I'm pretty happy with that. I'm going to clean this bottom up. We got some weld down there that just needs to be straightened out. I'm going to have to extend my tailstock out just a little bit farther. Just kind of facing that bottom shaft. There's some weld. It kind of sticks out. Now we're into the metal. I think that's good. And we'll put a chamfer tool on there and try to clean that up a little bit. And there we go. I think we have all of our turning done. These journals are ready for Babbitt. We'll be doing that in an upcoming video sometime, hopefully here soon. Like I said, I need to get this project knocked out and out of here and back into the hands of its owner. But we'll be getting to that later on. I think the turning turned out just fine, and we'll be moving along with this project. And with that, that's going to be a wrap on this project for today. So as always, thank you guys for watching. Please do subscribe to the channel if you haven't already. Thumbs up, comments appreciated. Hit the bell icon so you get notifications when new videos are posted. And guys, we'll catch you on the next video. Thanks again for watching.